Okay, so today we continue with the RC series parallel, and now we go into combine the circuitry with XL and XC. Okay, before we start with the LC circuitry, okay, I try to review. Make sure you must be understand for RC series, RC parallel. Okay, first thing we're talking about RC series. Okay, so you can see you get a circuitry R and C. Okay, so now only thing I want to know, if I draw the phasor vector for R here, where is the axis?
Negative j. Yeah, y.
The axis go where?
Down.
Going down. That means axis will be going down. That will be telling you are leading axis 90 degrees. This is my not 90 degrees. Okay. And now if you get the circuitry, same thing, but you get an inductor. Okay. So same thing, I draw R. Where is XL?
Positive.
Up 90 degrees. That's what you must
Right.
know. That will be XL. That means the IC and XL on the tab will be opposite. Okay? If I given you IC equal 50, XL equal 50. So the net inductive or capacity that will be in the net
Resistor.
total. They will be 50 minus 50. They will be 0. One going up and one going down. They opposite. And you already know, you get IL U pi FL. And I see 1 over U pi C. So now if the frequency going up, what happened to HL?
Increase.
Going
Increase.
up. I see.
Down.
Going down. That's just telling you one thing, okay? I see HL all the time will be opposite, okay? That's for the series circuitry. Now for parallel. Okay, I see. Only thing in parallel, the current will be different, right? That I see. And that will be IR. And you remember, if you want to calculate the total current, what I total equal?
Or root.
Square root, right?
Yeah.
IC square.
Square plus.
The reason is they're not in phase. Okay? And then if you draw for the phasor here, so where is the IC going?
Up.
Perfect. That will be IC, IR. Okay? And then also you can get the same circuitry. I turn it into the inductor. HL. Okay. Now, how HL go? IL.
Down.
Perfect. Now. So now you can see IC going up, IL going down. They will be opposite. Okay? That is basically only thing I need to make sure you're able to understand that before we go into the circuitry. Now, if they combine L and C, okay, they say for the circuitry with the IGLIC in series, the net reactant IT is the difference between two series reactant values because the for series LC circuit, IGL and IC 180 degree or phase. That's what I just talked to you. For HC and HL in parallel, the total current IT is the difference between two reacting branch current ILIC. This is the single ILIC 180 degree out phase. Okay, now we're talking about series. For the circuitry, look like here, we get right here. Cannot solving the circuitry with both L and C. Okay, that is a very important thing. You cannot solve for the circuitry with both HL and HC. The thing is one going up, the other going down. Okay, now what we want to do must be come up with either HC or HL circuit. That means if you get a HC, HL, then you have to come up with, it can be HC circuitry. Okay, they can be either HC or HL. They cannot both. Okay. Now, we need to calculate the first thing, the net reactant, HT or H doesn't matter. What that mean? That means they want to find out the difference between HL and HC. So HT will be equal HL minus HC or equal HC minus HL. What they're looking for is to see which one is bigger. And they say, if HL greater than HC, then the circuitry now will be inductive. They dominate by inductive. And if HC greater than HL, then the circuitry will be a capacitive. Okay? For this circuitry, HT equals HL minus HC, 160 ohm minus 120 ohm. So that's why you get 40 ohm. And they said this is a circuitry now will be inductive with the new value of HL will be 40 ohm. So now I redraw the circuitry here. Okay? Only inductor and the value of HL will be 40 ohm. Up to this point. Can you follow that? That means if you see HCHL, then you have to do a calculation to see which one is higher. If HC higher than HL, the circuitry, the new circuit will be capacitive. Or HL greater than HC, the new circuitry will be inductive with the new value of HL or HC. So in this calculation, HL 160, HC 120, the difference will be 40. And that HL greater than HC 40 ohm. That's why you get a new circuitry with inductor and the value for HL is not 160. They will be 40 ohm. Okay? And for the new circuitry, you easy to calculate the current total IT. Okay? So, IT will be equal to VT divided to HT 40 ohm. Okay,
Okay.
you get 3 amp. Okay, that only telling you for this circuitry with LNC, you cannot calculate the total current. The thing is they opposite it. That's why you need to get a new circuitry. And after you get the inductor uh, current 3 amp in here, then you can calculate the VL. That means the current right now in here will be 3 amp. You want to calculate the voltage, then take IXL times IT. That means you get 480 volt. And if you're going to calculate the voltage here, that will be telling you take the IT times IC. So the key point here is we're looking for the current flow in here. Okay? In order to get the current flow in here, then you must be come up with the circuitry, either IC or IL. Okay? They cannot be both. Okay, any question regarding into the IL and IC in theory? Make sure any confusing, any not quite understand, bring it up. So it looks like everything okay to you guys, right?
The one thing, maybe you're going to cover this later, is but if you change the frequency, then the inductive reactance and the capacitive reactance change. So the circuit could become more inductive or even capacitive,
That
right?
doesn't matter.
Yeah.
Okay. However, what I'm saying is, with the circuitry with both L and C, you cannot solve it. Like you want to calculate the total current. You cannot adding IC, IL, no, they opposite. So that's why you have to find a difference between IC, IL. If IL greater than IC, then you have to get a new circuitry with L only. And the value of IL, they not 160 ohm. They will be the new value, 40 ohm. Okay? Then you can calculate the current easy. You take the V total divide to IL, you can get the I total. And after you get the current I, you go back here. You can calculate the voltage for L1 and the voltage for C1. Okay, now quickly you tell me, doing calculation, tell me what you get in here. You have to try to do it to make sure you understand it. Okay, so now what net reactant?
20.
You can say I or you can say IT doesn't matter. However, there will be the difference between XL, XC, XL 30, XC, this is XC, okay? XC 50. So equal XC minus XL. So that will be 50 minus 30. You get 20 ohm. Okay? The circuitry now will be inductance or capacitance.
Capacity.
Perfect. Now new circuitry here. And the value here will be IC. Okay? Or you can say I. Equal 20. Okay? So now you can easily to calculate the total current. The 120 volt here. So I total equal V total divide to I. 120 divide 20. 6 amp, right?
Yep.
And now if you want to calculate the VC1 equal 6 times 50. $300 volt and VL1 6 times 30 180 volt. Okay? Any question? No? The thing that I believe you get quiz today, that cover on this part, okay? Make sure you understand, you can get through easy. Now, we're talking about parallel. XL and XC in parallel. The brand current ILIC will be 180 degrees out of phase. Then you must be come up either IL or IC circuitry, okay? And that first thing you need to calculate the ILIC. That's a very easy to calculate the IL. IL equal 120 divide to L 40. 3 amp, right?
Yep.
And then you have to calculate the IC. 120 divide 30. Okay? So, what you have to do, the thing is ILIC will be opposite. Then we have to know which current will be leading. Okay? If IL greater than IC, that's inductive. IC greater than IL, capacity. So now the circuitry look like a capacity circuitry. Okay? Let's see if we can get right here. Okay? I do calculation for you right here. Okay, so you come up with a new circuitry. Okay, on this one. I draw the new circuit. And that will be, okay, let's see, the net current flowing here, okay, that will be 1 amp. The thing is, I equal 4 amp, 3 amp. So that given you 1 amp, okay? So you calculate IL easy, IC easy. The net current, we already calculate for you, 1 amp, okay? And the net circuit it will be a capacity with the new value for HC. That means HC no longer equal 30. So that the new HC are in here, we say Z total equal HC. And HC will be 120 divide 1 amp here. You get 120 ohm. Okay, for the parallel, you need first thing you do a calculation for IC, then calculation for IL. That's simple. You take the V total divide HC, or V total divide HL. After you get ILIC, then now you have to calculate the net current. We're looking for either IL greater than IC or IC greater than IL. If IC greater than IL, then the new circuitry, okay, will be a capacity. In this case, there's a capacity right here. And the value of IC of the new circuitry, they're not the same like in the old one. In order to do the calculation for IC, you take the total voltage divide the net current. That given you the value for the new IC. Okay, in order to complete that, do this example for me. That means you need to calculate the current IC. VHC. Okay, that means 120 volt. Divide to 50. And that's why you get 120 divide 50. 2.4. And then you can calculate IL. V total. HL. 120. 20. You get a 6, right? So, I, the difference between ILIC, then you understand they will be IL. minus IC will be 6 amp minus 2.4. Okay. 6 minus 2.4, 3.6. So now you get a new circuitry with L. What they looking for, they want to know what a new value for inductor. So you can do the same thing. H L now will be 120 divide 3.6 ohm. Okay. See what you get.
$33.3.
Let's see. Divide 3.6. Total current will be 3.6 amp. Okay. And the total impedance, that means you take,
33.3.
okay, you get 33.3. How come here I put 20? Maybe I put a wrong one. Okay. So this is a wrong one. HL 33.3, right? Okay.
Mhm. Yeah, 120 divided by 3.6 is 33.3.
Okay. Yeah, I make a mistake. I take a L1 equal 20 from the original circuitry. They supposed to be 33.3. Okay, so you get HLHC in series, HLHC in parallel. That is we already done. Remember, you cannot solve the circuitry with both HC and HL. They must be come up with a circuitry with only HC or only HL. For the parallel, same way, they must be come up with a circuitry only inductive or capacitive. Okay, so that will be done for this part here. Okay, any question, anything?
Okay.
Oh, it's so easy. Okay. Now, we can go to the next one, RCL. Okay. This is RCL circuit. If you understand the basic for RC circuitry, RL circuitry, then will be no problem. You're working on RCL. The thing is, after RCL series, then we go to the next chapter different. Okay, like the transformer or the matching impedance and the filter and the resonance. That's a major in the AC circuitry. Okay, now first thing we're talking about RCL series. You're looking into this circuitry here. I equal 30 ohm, IC 60 ohm. IKL equal 20 ohm. So we already said you cannot solving the circuitry with both C and L. So now the first you need to do is try to calculation for the net reactant. Looking for IC, IKL, which one is higher. So here they say when the circuit combine RCL, own series reactant ICL to combine to the net reactant I. That means the difference between IC and ICL, like we just did it. IQ will be equal to IC minus ICL or IC will be equal to ICL minus IC. Okay, so now if you're looking here, ICL 20, IC 60. So basically, you can see net reactant will be equal to IC minus ICL. 60 minus 20, you get 40 ohm. Okay, so from this circuitry, now we come up with this one. Only capacitor with the new value
Mr.
for
Tam,
the reactant. Yeah, any question?
yes, I thought you're supposed to divide the V total by the XL or the XC to get which one is the greater, then to get to move to the next circuitry.
Now, you have to looking for the difference between reacting,
Oh,
not the current.
all right.
There's only one current.
Oh, yeah, because it's a series. All right.
Yeah, have to say IC, IL, which one is bigger. Right now, I'm looking, I say, IC 60 ohm, IL 20. I know IC greater than.
Yeah.
If
Thank you.
IC greater than, then you can get a net reactant right here. 40. 60 minus 20, you get 40. And the new circuitry, no more inductor. Capacitor only. However, the value of the capacitor here not same like original here.
Where you had the incense or missing a box of incense, a whole box is gone. Not in there no more. I don't know what happened to them. It was there though.
Okay, so basically from this circuitry, we come up with this circuitry. Okay, we had only capacity. A new value for capacity reactant will be 40 ohm. Okay, and they say the new circuit here, capacity circuitry. Up to this point, any question?
So the current is 3 then.
Okay, now, what next we need to calculate the total impedance. Now you can see, you go back to the RC series, okay, RC series. If you calculate the total impedance, then the square root R square plus X squared. That means R30, X40, and total will be 50 ohm. And after you get the total 50 ohm, you are able to calculate the total current, VT divided GT. That 120 divide 50, you get 2.4 amp. Okay? And if you want to calculate the voltage R, then you have to go back here. You already get the current. Okay, the current we do calculation 2.4. Current here is 2.4. Okay, and now you want voltage here 2.4 times 30. Voltage here 2.4 times 60. And 2.4 times 20. That's what we do calculation here. VR IT times R 2.4 times 30. 72 ohm. VC IT times XC 2.4 times 60. 144. VL IT times HL. You get 48. And now if you calculate the phase angle, then they will be 10 minus 1 of minus 8 divided to R. That means you're working with this circuitry. You get minus 53.13 degree. So you see that is so easy. So you get any question? RCL circuit. No?
I didn't get the point number 6.
You cannot get point number 6. Right?
Yes, can you explain the number 6 again?
Okay. Number 6, then you have to go back to what? R C series. Okay. Now let's see. I try to see I can get this one. I can carry you. Okay, let me. I thought I already uploaded that one, but it not. Okay, let's see. Formula. Okay. Just a minute. Okay, you see that? That is I already upload for you guys on of the formula.
Yeah.
Okay. So if you want it, then you have to go back into this circuitry here. Okay. And they given you everything. Okay. Total resistance, total current, VR, VC, and the phase angle. Okay.
All right, thank you.
Yeah. You
Okay.
did that.
Is that a PDF, Mr. Brown?
What?
Did you say you had that available as a handout or no?
Yeah. Uploaded from handout.
Thank you.
Oh man. Okay, let's see. RTL. That's what we're going here. Okay. So you get the formula and you're able to calculate the angle here. RC circuitry. Okay, now quickly, can you get through this one for me before we take the quiz? Okay. Net reactant.
50 ohms.
Okay, HL minus HC. Okay, 100 minus 50. 50 ohm. Okay, so now you can get a new circuitry. Only HL. Okay, in here, I not give it to you. Okay, but you will be come up with the circuitry will be look like. Here. L here. And this will be 100 volt. That's still 100 ohm. And now that one XL will be 50 ohm. Okay. So now
Mr.
you will
Pham.
be working on this circuit.
Hey, Mr. Pham,
Yeah.
my question is, since you know that X of L is 100 and X of C is 50 and 100 minus 50 is 50, and at that point, you can call X of L, right?
Yeah, I suppose.
Because the circuit is inductive at that point.
Exactly.
Okay, thank you.
So sometimes I using I to make it different from original.
Okay, thank you.
And then if you want to calculate the total impedance here, you didn't remember the formula. Open the handout I give it to you. So basically G total square root R square plus I squared. Then if you want to calculate the total current IT, that means now you're working with only one circuitry, RC or RL. Okay, IT equal VT divide G total. Okay, so whatever you calculate the G total here. So who get the answer for number 2? Square root of 100 plus square root of the 50.
111.8 ohms.
That's what I got. 111.8.
What you get?
111.8, the same thing that you, Luke, got.
Okay, 111.
0.8.
110, right? 11.
No, 111.8.
Is it right?
111.8.
Yeah, 111.8. Hundred. Okay. And after you do get the total current, and now no matter what you want to calculate the total voltage here, then take the value R times current. You want voltage here, take the total current times IC. And finally, you want to calculate the total voltage of inductor. Take IT times 100. Only thing is they want to know the phase angle.
Mike, did you get 0.89 for the current?
Yeah, I did.
Who remember the formula calculated? Phase 10 minus 1 of what? I believe I divide QR.
Yeah, that's going to be 50 over 100. And then arctan.
Equal how many degrees? Is it 45 or what?
$26.56. Is that what you got, Mike?
I could be 50. Divide 100.
Yeah, I got 26.5.
$26.56 degrees, Mr. Pham.
Yeah. 26.6.
Yeah, that's good. That's good enough. Hey, Mike and Mr. Pham, did we miss something? Is there a minus on this or what?
No, it's not minor.
Oh, no. Okay.
So that's why I given you the sheet for formula.
Yeah, I know, Mr. Pham. I know.
Yeah, you want to just open that. I don't want to remember anything.
Okay.
Okay, any question up to this point? Okay, if it's not, okay, I will be stop share that my iPad. Okay, hello Sam.
Yes, Mr. Pham.
You ready for the test?
No.
Come on. Yeah.
Okay, so you want to run test number 5. Okay.
Right, exactly. I only
Okay.
you.
Certainly. Okay. Test number 5. So everyone, make sure you download the test report from the website. And let me go ahead and run okay, we're going to run this test. Okay, play from beginning. Okay, here's your first question. Can everyone see? Yes?
Yeah.
No?
Yes.
Okay, good.
Well, this time we'll let 100.
We'll see. Okay, so that's pretty much it.
Can I see numbers 9 and 10? Thank you.
Welcome.
Can I see number 4 and 5, please? Four and 5.
Okay,
Yeah.
so that's it. Okay, Mr. Pham, do you want me to go ahead and go over the quiz number four?
Next
Number
time,
8, Sam, please.
Next time, okay.
Monday.
Okay, Monday number, and then I have to go through 4 and 5. Okay, on Monday. All right.
The thing is, that will be long, right?
4, no, it's not going to be too long. It's not probably in about 10 minutes.
Okay, go ahead, do it.
Okay, so what was the question that?
Number 8, please.
Number 8, okay, sorry. All right. So they want I total. Okay, let me go ahead and share number 8. Okay, so that's number 8. Okay, so you're good.
One
All
through
right.
20, please.
Yes, thank you.
You're welcome. Okay, now let me go ahead and go through the quiz number 4.
1 through 20, please.
Sorry, we can't go there. Okay, so this was this one they want the maximum amplitude. Okay, it's question number 1. The maximum amplitude of AC waveform in either polarity is either. So we're going to be looking at that. So it's this one here. It's this signal here. So this wave here. So from this point to this point is just the peak. Okay, so on either polarity, on the positive, it's going to be just the peak. On the negative, it's also on the peak, but it's on a negative peak. So the answer is C as in Charlie for number 1. Okay, number 2, one complete repetition on AC waveform is this one is 1 complete. So it goes up and then comes all the way down to the bottom and then comes up here, represent 360 degree. It's called a cycle. So that's C as in Charlie for number 2. Okay. And number 3, if the voltage peak of a sine wave is 70 volt, then the VRMS is, so this is, they're assuming 70 volt peak. Okay, so 70 volt peak. So if you take that, so VRMS, the formula is 0.707 times V peak. So therefore it was 0.707 times 70. The answer is, comes up to 49.49 voltage RMS. So the answer is B as in beta for number 3. Any question? No. Okay. Next one. Page down. Okay. All right. So number 4, find the time constant of a circuit containing 100 kilo ohm resistor in series with a 20 microfarad capacitor. Okay. So resistant is 100 kilo ohm. So I converted to ohm. And capacitor is 20 microfarad, so that's 0.00002 farad. Okay, so my time constant equals RC times, so RC, so R is 100,000 times 0.0002 farad. That's, you can multiply that together. It comes out 2 seconds. So 2 seconds, A is the A as in alpha for number 4. Okay, number 5, when the phase angle is measured by an oscilloscope, a lagging waveform is, okay, so just almost like car racing. Okay, which of these signals comes first, all right? So look like the peak, the blue ones comes first, but the one that's coming behind is the one that's lagging behind the whole thing. So it's the red one here is lagging. So the one that is shifted to the right of the reference point, that is your lagging. So the answer is C as in Charlie. So that shift toward the right of the reference point, reference waveform. Okay. Number 6, an oscilloscope that can directly measure AC and DC voltage. Okay, because you can set it up because you can set it up and it can measure AC as well as DC voltage. So A as an alpha for number 6. Any question?
Nope.
Nope. Okay, next one. All right. Okay, 7, the reciprocal of a frequency of an AC waveform equals to, okay, so T is equal to 1 over F, or same thing as the period equals 1 over frequency. So therefore it's the period. So the answer is D as delta for number 7. Number 8, when oscilloscope control setting is used to measure time, okay, that would call a time-based oscilloscope. So that's D as in delta for number 8. Okay. The equation XC equals 1 divided by the quantity 2 pi FC is valid for, mainly it's can only valid for AC waveform only. Sine waveform only. So D as in delta for number 9. Okay, any question?
Sam,
Yes.
so can we have an AC waveform that is not a sine wave?
Yeah, you can say AC waveform, you can do a square wave. Okay.
So that
So
is not.
yeah, so when you have a square wave, so square wave is, yeah, square wave and the triangle wave,
It's
you
all
can do that.
two-way.
When they're talking about all AC waveform, they have everything. So you have the triangle wave, you have the square wave, but the only one that will definitely works on all the time, it would only work on sine wave. Okay, so we want a perfect, so it's almost a perfect, so going through. So you need a complete sine wave, just kind of wave like that. Okay, so it's only applied to, let me see, going to apply just to, yeah. So mainly we're going to be just applying mainly to the sine wave signal. So like this here.
All right, thank you.
Okay, you're welcome. Yeah, when they said all AC waveform, it cannot apply to all of them. Okay. So, okay, so next one here, let me see, scroll this up a little bit. Scroll down a little bit. Okay, so the capacitance is the ability to mainly to hold the electric charge in the capacitor. Okay, so the answer D as in delta for number 10. Magnetic field, that is only in the inductor. Okay, so in this one's induced voltage. No, we don't induce anything. The only thing is holding the electric charge, electrons for capacitor. Okay, so number 11, a capacitor is considered to be fully charged after how many seconds? Okay, so therefore it's off from this here, okay? So you look at, so this one would be 1T is only charged up to 63.2%. And then 2T is only 86%, 3T 95%, 4T is 98%, and 5T would be almost at the maximum, which is 100%. So the answer is C as in Charlie for 5 for number 11. Okay, go back, let me see, go back into that. Okay, next one, number, let me see, we can just do this one. Okay, capacitive reactant XC lies on which axis of the XY coordinate plane? Okay, this one Mr. Pham just went over. It's going to be on the negative Y axis. Okay, so B as in beta for number 12.
Question.
Okay. Yes.
Which one is X and which one is Y? Can you just
XY coordinate, just almost like your plane coordinate, right? It's like, okay, right here, this would be your Y axis that's going up like this, okay? And the X axis is this here.
Okay, thank you.
Okay, you're welcome. Okay, any question? Okay, next one. Okay, 13, the transfer of energy from one circuit to another. Okay, so this one is just a definition. You can Google the information. This one said it's called coupling. So the answer is B as in beta for number 13. Okay, so number 14, the time constant RC specified the time it takes C to charge to what percentage of the charging voltage. So therefore they're referring to when it's first charged up. So when you hit the first T, it's going to be the first T is going to be at 63.2%. Okay, so the answer is B as in beta for number 14. Okay, number 15, a very common use of capacitor is mainly to block the DC, and they allow the AC to pass. But so this one look like there's nothing here about A's the opposition to AC. No, A is not correct. The only one that's correct is B as in beta for number 15. Okay, have any question? Okay, so next one. Okay, so now we just go through the circuit, which is mainly do the calculation that we just use all the formula that Mr. Pham just gave you in the website. So that pretty much, so total impedance, ZT. So this one is going to be, so ZT equals the square root of R1 square plus XC square. So therefore you're going to put 180 ohms square plus 120 ohms square. And that's, and take the square root of that, that's come to 216.3 ohms. So well, like I said, well, this is a range. If you put the calculation, this is the actual value, but 210, it would be correct. So anything 210 up to 216, a little bit above this, it would be still correct. Okay. So the next one is number 17, total current IT. So IT equal to E divided by ZT. So E would be 50 VAC divided by 216.3 ohms. So the answer equal to 0.231 amps or 231 milliamps. So I tried to keep all the number, the original number, all the placement value. So that's why I have this one. It's more accurate, but you definitely, this one is usually based on the rounded off number. Okay, so that's why this one's come to 227.5. So anything within closest is close enough. Okay.
Oh, that 231 is more or less the answer though, huh?
Yeah, this one would be the, if you keep all these exact value, yeah, this would be the exact
231
correct value. Okay, but yeah, 210, 227.5 would be close enough, you know, depending on if you round up the answer here on number 16 and then your answer in 17. Okay, any question? All right, next one. Okay, so we're going to be 18 capacitor voltage VC. Okay, so VC equals IT times V times XC. Okay, we got the current from previous step, which is 0.231 amps times 120 ohms. So that's a VC would be equal to 27.73 VAC. So like I said, depending if you use the number that was rounded off, it's come to about 26.5. So anything within this range will be good enough, okay? We just make sure that you understand the concept and just apply the formula correctly, okay? So next one, the VR equals, so the resistant voltage, VR equals IT times R1, okay? So therefore 0.31 amp times 180 ohms. So that's come to 41.6 VAC. So this one comes to 43, so that's close enough.
Hey, Sam, not to beat up anything, but those answers that you got in black, if they have those answers, they would still be correct.
Correct. This, yeah, this is based on my own this is on my calculation that I keep. Like I said, I keep all the number of the exact value. This one has multiple digits, so therefore I don't show them all here. Just shows the 3 digits here.
So if those black answers like you got right there, where the red answers are that were values that you still get correct.
Yeah, this is accepted. These are the value of Mr. Pham. It's that this is the value that he's want you to go with, and this is from the actual calculation. If you keep all the exact number, and so, okay, so either one it's fine. Within that range, it's going to be fine. It's good. Okay. So the phase angle. So this one is XC. So this one is it's a series. So there's going to be negative VC. Okay. So phase angle is the arctangent of negative VC divided by VR. So negative 27.73 VAC divided by 41.6 VAC. So your theta comes about negative 33.69 degree, rounded up to negative 34 degrees. Okay, so now number 20. Okay, any question? No? Okay, next one. Okay, we're almost there. All right, so hey, we're gonna finish it almost on time. Okay, so 21, capacitor current. Okay, so capacitor's current is gonna be IC equals E divided by XC. Okay, so E is 100 VAC divided by XC is 50 ohms. Okay, so 100 divided by 50, that would be 2 amps RMS. Okay, and the next one, IR, or the resistant current, equal to E divided by R2. Okay, same thing as 100 VAC divided by 100 ohms. That would give you 1 amp RMS. Okay, and then we want to calculate the total. So therefore, IT is equal to the square root of IR squared plus IC squared. So therefore, square root of the quantity 1 squared plus 2 squared. That comes up 2.23 amps RMS. Okay. Any question?
When you get a chance, Sam, go back to 20, please.
Okay, 20. Oh, 20. Okay.
Thank you.
You have a question on that 20 or just
No, that's it. Go ahead.
want to see the work? Okay. All right, so that's done. Okay, 23. Okay, any question on this one, number 21 to 23? Okay, next one. Okay, so this is the last one, last two. Okay. For the above circuit, okay, so total impedance ZT, okay, so ZT, so this one is XC and this one is going to be 100 ohms. So you're going to be, in this case, we're going to just use E divided by IT, and we got IT from previous step, which was what 2.23 amps RMS. So, and then you got the E, it's 100 VAC. So divided by that, so you got a 44.7372 ohms, and look like rounded up so to 43 ohms. So okay, so 25, the phase angle. Phase angle equals arctangent of IC divided by IR. So this is how to deal with current. So therefore, that's why we have positive here instead of negative degree. So since we deal with current, it's going to be a positive angle. Okay, so arctangent of the IC was 2 amps RMS divided by 1 amps RMS. So you do that, your calculation comes to about 63.43 degrees or 62 degrees. Either one will be acceptable, or within that range, it's more than acceptable. Okay, anybody have any question? No question? Okay, well, that's it for me. Thank you. Back to you, Mr. Pham.
Thank you.
Thank you very much.
Thank you.
Okay, so good night. We'll be
Bye,
see
everybody.
you next week.
Okay, see you next week.
Good night. Good night.
Good
Bye-bye.
night.